Today we're going to talk about slopes of parallel and perpendicular lines, section 3.8. So we're going to start with parallel lines. If two non-vertical lines are parallel, then their slopes are equal. Now we have to say non-vertical because a vertical line has an undefined slope. So we can't talk about vertical lines in terms of slope. We'll talk about those in a minute. But all other lines, non-vertical lines, are parallel. Their slopes are equal. You can notice that this is a conditional statement. If the slopes of two distinct non-vertical lines are equal, then the lines are parallel. This is the converse of that statement. So we have it both ways. If two non-vertical lines are parallel, then their slopes are equal. And if the slopes are equal, then the lines are parallel. Then we also add a third statement to take care of our vertical lines. Any two vertical lines or horizontal lines are also parallel. Okay, so we're going to first of all talk about checking for parallel lines. If line A contains the point -13, 6 and the point -1, 2, and line B contains the points 3, 6, and 6, 7, are the two lines parallel? Well, the way I'm going to determine that is by finding the slopes. So the slope of line A is y minus y over x minus x. So that's -4, -1 plus 13 becomes 12. -4/12 is -1/3. And we do the same thing for the slope of line B. You notice that I use a subscript just so that I know which one I'm referring to, line A or line B. And this is going to be 7 minus 6 over 6 minus 3. 7 minus 6 is 1. 6 minus 3 is 3. They are not identical. One has a negative slope and the other has a positive slope, so they are not parallel. The second thing we're going to do is write equations of parallel lines. So if I have a line with the equation y equals -3x minus 5, I want to write an equation of a line parallel to this line that contains the point -118. So write all that down. So this line looks something like this, with a slope of -3, probably a little steeper. Okay, but it passes through the point 0, -5. That's its y-intercept, and it has a steep slope. Now I want to draw a line that's parallel to that. There are lots of lines parallel to my line. I want the one in particular that goes to the point -118. Okay, so I want the parallel line that goes through that specific point. So what I know about parallel lines is that the original line and my line, the one passing through the point -118, have to have the same slope. So the slope of the first line is -3, so the slope of my line will also be -3. So I know the slope of my line, and I know an ordered pair. So all I have to do is use point slope. Y minus 18 equals -3 times x minus a -1, and I get y minus 18 equals -3 times x plus 1. To put this into function form, where we have y equals, I'm just going to move the 18 to the other side. And that's an adequate equation of the line. So, checking if lines are parallel, we compare their slopes. Writing an equation for a line parallel to another line, we use the slope of that line as the slope of our parallel line, and we use the given ordered pair. Okay, perpendicular lines. If two non-vertical lines are perpendicular, then the product of their slopes is -1. We have also seen that their slopes are opposite reciprocals. So if one line has a slope of 2/3, the slope of the perpendicular line, this symbol means perpendicular, is -3/2. So we've often seen it written this way, but we can also say now that if we take my first slope and multiply it by my perpendicular slope, I will get -1. So it's kind of a quicker way of saying this. So if two non-vertical lines are perpendicular, then the product of their slopes is -1. Here's our converse. If the slopes of two lines have a product of -1, then the lines are perpendicular. And then our statements take care of vertical lines. Any horizontal line and vertical line, one of each, are perpendicular. So write those down. And let's see what we can do with that. So checking for perpendicular lines. So again, we need to find the slope of each. The slope of A will be 7 minus a -1 over 2 minus 3. That's 6 over -1, or -6. The slope of line B will be 7 minus 6 over 3 minus a -2. So that's 1 over 5. They are well, they're not reciprocals because that doesn't say 6. So these are not perpendicular lines because -6 times 1/5 is -6/5, which does not equal -1. So again, writing equations of perpendicular lines. What's an equation of the line perpendicular to this one that contains the point 15, -4? Well, the slope of the original line is 1/5. So the slope of the perpendicular will be -5 over 1, or -5. So using a slope of -5 and a point of 15, -4, we can write our equation of our new line perpendicular to the original. Notice the slopes. So y minus a -4 equals the slope times x minus 15. Okay, and again, if I want to write this in a little nicer form, my pen is not working well for some reason. I can move that 4 to the other side. Y equals -5 times x minus 15 minus 4. Okay? And I think that's it for today.